All right, so in the Math 1 book, at page 95, it says factor the polynomial completely. So that's what we intend on doing on numbers 13 through 24. Here we go. 7x cubed plus 28x squared. What you're going to look for is a greatest common factor. It's just two terms. It's not a difference of squares or anything like that. You just see that these are multiples of 7, right? And you also see that there's an x squared that's in common there. So 7x squared. And when you divide that by 7x squared, you get x. And just make sure that when you multiply these two, 7x squared and x, you would get that first term. Plus, if I took a 7x squared out of this, I would end up with a 4. Okay, and actually you are finished right there. Alright, number 16. 48r cubed minus 30r squared. There is a minus sign, so it could eventually be difference of squares, but first thing you always want to do is check to see if there is a greatest common factor. In this case, I know that 2 goes into both of these, so I'm going to try that first. 2 goes into this 24 times. 2 goes into this 15 times. 24 and 15 also have something in common. So I think there's a bigger factor that goes into 48 and also into 30. That number is 6. 6 goes into 48 8 times. 6 goes into 30 5 times. Okay, so I'm going to take out a 6 instead of a 2. I'm going to take out a 6r squared, and I'm left with 8r minus 5. There you have it. Finished. 19. This looks like a trinomial, right? You might initially think, oh, Lizzie method, but don't think Lizzie method until you have taken the greatest common factor out first. Greatest common factor is 5, because 5 goes into all of these. And now I have m squared plus 4m plus 8. 5 times 4m is 20. 5 times 8 is 40. Okay, just checking myself there. Alright, so now what multiplies up to 8 and adds up to 4? 4 and 2. No, 4 and 2 multiply up to 8, but they add up to 6. So not 4 and 2. Not 8 and 1. Is there anything that multiplies up to 8 and adds up to 4? The only factors I can think of are 2 and 8, and that doesn't add up to 4, and also 8 and 1, and that adds up to 9. That's not 4. So actually you're finished here. All you had was the greatest common factor. Okay? 22, 9x cubed plus 36x squared plus 36. Is there a greatest common factor? Yes, 9 goes into all three terms. So here's a 9, and now I have x to the third plus 4x squared plus 4. If this was a quadratic, then maybe I could factor it a little bit more, or at least I would try to. But this is actually finished since it's a cubic function. So it's finished. All right, 23. Ooh, it has 4 terms. What do you do with 4 terms? I'm going to put this page back up here again. When you have 4 terms, polynomials with 4 terms, you have to factor by grouping. That means you group GCF, then GCF. Group, greatest common factor, greatest common factor. So our first step, going to group, and then I'm going to look for the greatest common factor here, x squared, x plus 1. Look for the greatest common factor here, 5, x plus 1. So we grouped in the first step, we did the GCF here for both binomials, and now we do a GCF again. What's the greatest common factor of this term and this term? What's the greatest thing that they have in common? Is that x plus 1. And you're left with x squared plus 5. So this is our answer here. Alright, so I hope this is helpful to you. Please learn the material, learn how to do this without videos. Factoring is essential to learning mathematics. But again, that was page 95, numbers 13 through 24. Bless you.